Hello, welcome to Math 2019, and in this video I'll go through question 1A. And for this question, we are given this equation, x cubed minus 200x equals 3000, and they want to know how many solutions does this equation have. Alright, so would it be easy to factorize this equation and find out its roots? I don't think so. I think it would be quite difficult. So how else can we go about this? So we could do this graphically instead. So here are my axes, and I can plot the left-hand side and the right-hand side separately, and when those two curves intersect, we'll have a solution to this equation. So let's plot these curves. So let's do the right-hand side first, because that's easier. So it's just a number, just a constant. So we'll just get a straight line, y equals 3000. And on the left-hand side, we have a cubic. And I guess we don't need to know exactly what this cubic looks like, but it's not very difficult to find its roots. So if I put it equals to 0, can you factorize this cubic? Well, we can take the x out. So we have x times x squared minus 300, and from this we see that its roots are x equals 0 and plus and minus root 300. So we have three roots, 0 plus root 300 minus root 300, so our cubic is going to look roughly like this. So we can see we're going to get an intersection over here on the right, but what about over here on the left? So from the way I've drawn it, it looks like we're going to get two intersections, but does this necessarily have to be the case? Can you see the other possibilities for what our cubic will look like? So one of the possibilities is, instead of our cubic going over the straight line, it just touches it instead, so it's tangent at this point. And the other possibility would be that it doesn't go anywhere near the straight line, and in this case we would only have this one intersection here. So three possibilities: we either have one or two or three intersections, so one or two or three solutions. And what property of the cubic are we going to have to look at to figure out whether it is 1, 2 or 3? Well, we're going to need to know where this maximum is, right? Whether it's above the straight line, on the straight line, or below the straight line. Okay, so how are we going to get this maximum? Let's differentiate. So we have y equals x cubed minus 300x, and differentiating gives us 3x squared minus 300. And if we set this derivative to 0 to find the stationary point, we get 3x squared minus 300 equals 0, and we can cancel out the 3's, which tells us that x squared is equal to 100, so x must be plus or minus 10. And now for this maximum, do we want plus or minus 10? Well, we can see it's going to be at a negative x, right? So this is going to be at minus 10, and the minimum will be at plus 10. Okay, so that's the x-coordinates of the maximum, but we need to know the y-coordinates to know whether it's above, on, or below 3000. So to find that, if we put our x-coordinates back into our equation, so just subbing in x equals minus 10 in, we get minus 1000 plus 3000, because we've got plus minus a minus. And 3000 minus 1000 is definitely less than 3000, right? So the y-coordinate of this maximum is going to be less than this line. So we're in the purple case here. So we can tell there's only going to be one intersection, which means we have exactly one real solution, which is answer B.